All right, as we kick off the next unit, it's about chemistry of life. So we're going to talk about some basic chemistry, and this is probably a course that a lot of you are going to take in the future. The two questions we're going to be able to answer at the end of this week is how is water essential to life, and what role do acids and bases play in living organisms? So what you'll learn about this week is how different elements are involved in making up living things. So here we have an image of the periodic table, and don't panic, you do not have to memorize what all of them mean or what they do, but that's something you'll definitely get more involved with in chemistry class. We are concerned about a few elements in biology that I want you to write down in your notes. So if you need to pause the video and get your notebooks, that's important. You can do that now. The elements you need to know for biology are CHNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So I always like to call them CHNOPS to help myself remember this. Now, don't get to the point where you think, oh, it's just the first name of the first letter of the element, because that's not the case. So you should, on your own, look up the symbol for iron and iodine. So look up the symbols for iron and iodine. The next thing we're going to do is I want you guys to write down that 99% of all living organisms are some combinations of these 6 elements. So humans are going to have similar compositions for their elements, but a human and a plant, we may have these same elements, but we might have them in a different amount. Prefixes to help you understand chemistry and biology. The prefix mono means one, di means two, and poly means many. And these will have a few applications as we get going. So you want to just have them kind of written down and remember that. The next thing I want to review, and maybe this is a review for some from middle school, or maybe this is some new information, but it's about chemical bonds. So one thing that these elements have in common in the periodic table is, depending upon where they are in the periodic table, they have protons, electrons, and neutrons. And they have electrons, which are negatively charged parts, and that's what these blue dots are. They're representing electrons. And those electrons want to be happy or balanced. And in order to do that, they might be given away or accepted, or they may share. So we're going to take a look, a very simple look at those 3 types of bonds. So in this image here, we're showing an ionic bond. You see, this is sodium, this is calcium, and you can see them kind of agreeing that sodium is going to give away one of its electrons to chlorine that is looking for one of the electrons. And by doing that, they form a bond between each other. So it's a great image that kind of just shows what's happening here. So in your notes, write down 3 types of bonds: ionic, covalent, and hydrogen. And we're going to take a closer look. An ionic bond is going to be a bond that involves transferring of electrons. So I know there's quite a wordy definition here, but I want you to always be comfortable with kind of summarizing it into something that you can understand. So an ionic bond is transferring of electrons. So this sodium is giving away one of its electrons. When sodium, Na, gives away one of its electrons, it's actually becoming more positive, so you'll see a plus sign. When chlorine's accepting one of the electrons, it's actually becoming more negative. So it's accepting an electron. You can see that right here. It has a negative sign. So that positive and negative, those opposites are going to be attracted to each other and form NaCl. That was an ionic bond. A covalent bond is when there's sharing of electrons. So they're not really giving and taking, but they're willing to share. So a single covalent bond is when one pair of electrons is shared. So that's actually shown down here below between hydrogen and chlorine. They're sharing one pair, and that's represented by a single solid line. A double covalent bond is when there's two pairs of electrons that are shared. That would show two solid lines. And a triple bond would be when there's three solid lines. And again, this is sharing of electrons. A hydrogen bond is shown with a dashed line. So a hydrogen bond is usually a bond between two molecules, not in the same molecule, but two molecules. This is one water molecule, hydrogen bonded to another water molecule, hydrogen bonded to another water molecule. Hydrogen bonds are shown as dashed lines, and it also should give you a hint that they're not as strong. Second to last concept is this idea of something being polar or nonpolar. So I mentioned that there's some sharing of electrons going on, but as we all know, sometimes it's hard to share something equally. For example, if I have 7 Oreo cookies and there's 2 people, only way is to split one Oreo cookie in half, 3 and a half, 3 and a half. But more likely, one person's going to get 4 cookies and one person's going to get 3 cookies. That's an example of a polar molecule. That molecule is going to be pulling a little bit more weight, so to speak, or more electrons, and it's going to have a more slightly negative charge. And that's what happens with water. The oxygen pulls a little bit more of those electrons, which makes it more negative than the hydrogen end. Whereas nonpolar, there is completely shared electrons, or shared equally, and there's no positive or negative end. So you'll hear these terms polar and nonpolar. The other terms you'll hear, hydrophobic versus hydrophilic. So let's talk about these prefixes. Hydro means water. Phobic is fearing, and philic is loving. So phobia, a hydrophobic, means scared of water, and hydrophilic means truly loving water. Hydrophobic is a good example of a nonpolar molecule. They don't want to mix with water. Oil and water is a great example. If you can go to your kitchen and you can put a little bit of oil and water together and see what happens, you'll probably notice that they do not bond together. Oil usually kind of just floats at the top. Hydrophilic, on the other hand, is something that will bind to water. So maybe mix some salt and water and you'll notice that what you end up with is salt water. So we're going to take a look at those terms throughout the week as we learn a little bit more about water and then acids and bases.